Hello, I'm Christoph Gard with the University of Kaiserslautern. In the following, I will tell you about a quick and easy way to get started with using TTK and experimenting with it using a virtualization technology called Docker. For those of you that have not heard about Docker or haven't had a chance to employ it, let me give you a very brief rundown. In brief, Docker is a virtualization technology, not unlike virtual machines, that facilitates the creation of well-defined software environments. A typical use case is to package an application with all its dependencies, that is, libraries that it needs to run, and potentially other resources such as data files. In Dockerland, all of this is packaged into a so-called container, which can be used on any machine that has the Docker tools installed. The advantage of using containers over other means of packaging, such as a system's package manager, address one of the most difficult challenges of working with scientific software, which is getting it installed in the first place. The runtime environment in a container is, well, self-contained, so there are no conflicting library versions, no need to recompile on unrelated system updates, no platform-specific problems such as, for example, the difference between Ubuntu and CentOS, etc. I could go on for a while. The list of potential problems when using scientific software from source is very long. If you have compiled ParaView before, you know what I'm talking about. So containers in many cases solve these problems, and we can make use of this by packaging TTK and its dependencies, most notably ParaView, into containers. This completely eschews any need for manual installation or compilation and any dependency problems or long compiles. If you have worked with virtual machines before, this may all sound quite familiar. VMs package an entire machine environment and implicitly also all applications and dependencies installed on the machine. A Docker container, however, does not package an entire machine, and so it can be much more lightweight. For example, the TTK virtual machine provided for this tutorial weighs in at more than 10 gigabytes, whereas the Docker image packaging the same software is about 1.4 gigabytes in size. Furthermore, the light virtualization that Docker provides is also reflected in the startup time. A virtual machine has to be booted, the operating system has to be started, and so on. Whereas a Docker container is basically a process on the host machine, and so it can start very quickly. Before we move on, let me take note of the terminology around Docker. In Docker parlance, a container is a running process with some application inside. Containers are initialized from so-called images, which are essentially snapshots of containers. And finally, the Docker engine is the piece of software that you need to install on your machine. It is the tool that is responsible for running and executing containers. So if you want to use TTK with Docker, you need to install the Docker tools. This is actually easy to do. While Docker isn't open source software, it is free to install and use. So as long as you have installation privileges on your machine, you can follow this approach. Here at the bottom, I'm providing links to installation instructions for some of the most often used operating systems. And typically this amounts to running an installer or installing a package through the package manager. So this is quite easy to do. Okay, so let's see how we can leverage Docker to easily experiment with TTK. We will do this using containers that contain both ParaView as well as the TTK plugins for ParaView. ParaView can, by design, operate in a client-server mode. This means that the server, where all of the data resides and computation is executed, may run on a different machine than the client, which is basically the GUI. In other words, we can run the ParaView GUI to control the server running on a different machine. Originally, this is intended to facilitate visualization in supercomputing, where the GUI typically runs on a local desktop, but the server may reside on a supercomputer or cluster of some kind. However, we can hijack this mechanism and utilize the client-server nature of ParaView to work with Docker containers. While the ParaView GUI, the client, will run as a native application on the host desktop, we can stick the ParaView server into a Docker container, where it is installed including the TTK plugins. The local GUI and the server in the container can talk to each other through a Docker facility called host container networking. In this scenario, we don't have to do any compilation. For the client, we can simply use an off-the-shelf stock ParaView binary available from Kitware's website for all major platforms. For the server, we use a Docker image that has ParaView with the TTK plugins. It doesn't matter that the client, the GUI, does not have the TTK plugins. We will still be able to use the server's TTK plugins due to some magic that ParaView is working behind the scenes. By far the simplest way to get all of this up and running is to download Docker, a ParaView version from Kitware's website, and to install it both on your machine, and then open a terminal and run the convenience script provided in the TTK repository. This will automatically detect the ParaView version you have installed and run a matching server in a Docker container. Also, this will make available to the server your home directory such that you can access data from there in the server. For more complex setups, for example, if you have multiple ParaView versions installed, you can optionally supply the path to one of them. Once the container has started up all right, the client GUI will be launched on the desktop and automatically connect to the server. The script doesn't do anything too fancy, and in fact it simply invokes the Docker command to start a container. You could also do this manually for a little more control of what specific versions of Paraview and TTK you want to utilize, or to make other data directories available to the server. Just to give you an idea, I'm showing you here the Docker command needed to run a Paraview 5.8.1 server with the TTK plugins from the developer series. Docker run tells Docker to run a container, and the final argument, here highlighted in brown, is the name of the image used to initialize the container. The other arguments here take care of making sure the container is temporary, allowing it to see Paraview output and providing access to the home directory without problems. So let me show you how easy this can actually be in practice. Here I am on my local Mac desktop, and here in the terminal I've already prepared the command to run the Paraview server Docker container with the TTK plugins. I'm going to show you the manual process. So let's run this. The image isn't found locally, so Docker will automatically download it, which may take a while. And now that the image is downloaded, it's automatically started up, and we can see the output from the Paraview server, which is accepting TCP connections. So let's fire up the Paraview GUI. And here we are. It's just the Paraview GUI as usual. There's no sign of any TTK plugins or anything, but once we connect through this icon here to the server on the local machine, we can simply click connect here. And then Paraview will show us this little window where it tells us that it has found plugins on the server side, namely Topology Toolkit, that are not present on the client side, that were connected to the right container. And as we can see now, the TTK plugins are accessible. So for example, we can use the icosphere source to produce this beautiful icosphere. Let's try to load a state file to see whether all the computations run on the server. I've conveniently already downloaded the TTK data repository, and there are some state files in there. Let's use the Dragon here. And the only thing we need to do is to tell the Paraview server that it can find the data files in a specific location. And note how this is still the path to my home directory, just as I would use it in the local machine. So let's hit OK here and wait for the state to be loaded. All the computations are re-executed, and here we get the Dragon just as if we would run it on a local machine. Let me note a couple of things before coming to an end. First, it is entirely possible to go beyond host container networking to connect the Paraview client and the server, and have an arbitrary internet connection in between them. This means that the Docker image can be run remotely, maybe on a more powerful machine, as long as a TCP connection from the client to the server is possible. This means that you can quickly try out things with TTK on your local machine and then run on a larger data on a bigger machine, all while controlling things from your local GUI and using the exact same software version and runtime environment. The downside is that in order to run the server container on any machine, you need superuser privileges to access Docker. This does complicate matters a bit, especially in supercomputing environments where root access is not commonly available. Let me, however, point out that in these cases, Singularity can serve as a stand-in for Docker. It is a tool that is especially aimed at such environments. And the good news is that you can use TTK Docker containers directly with Singularity. I don't have time to go into this here, but if this is your use case, I strongly encourage you to check this out. Secondly, all of the scripts needed to build the TTK and Paraview Docker container are part of the TTK repository. So do feel free to customize and build your own containers as you see fit. Your mileage may vary when combining versions of TTK and Paraview, but installing any extra software, etc. are easily done. Check out the Docker documentation to learn more. Currently, we are providing the following containers available from Docker Hub. These are the combinations of Paraview and TTK that build cleanly together. So, to conclude, let me summarize the message I've tried to convey here. Trying out TTK or getting started with topological analysis for visualization requires nothing beyond an internet connection and a couple of minutes to download Docker, Paraview, and a matching TTK container. No compiles are required on your machine. In fact, it isn't even necessary to have a compiler installed on the machine you are working on. Plus, there are some extra benefits of working in this mode, such as network transparency and the Python interface, at typically negligible overhead. If you're interested in how things work behind the scenes, or even better, if you want to help improve the TTK Docker experience, let me point you to the TTK repository on GitHub. Contributions there are always welcome. With this, I'm done. Please enjoy the remainder of the tutorial. Christoph out.